which means you might need a larger member size, and then goes to, as I said, it's not functional in all applications. So if you have cantilever, unfortunately, you're stuck with a moment connection. So the whole point of this little section is just to explain that whilst a pin and a moment are both acceptable connection details, we just need to be a little bit aware of where we're using them. So if you just had a concrete beam, say steel beam spanning between a couple of steel beams, and the ends were, whatever the structure was very flimsy, you may be concerned if you were using a moment connection in that that structure might not be able to take that. So using those sort of general principles we spoke about before, they're just things that you might be able to identify in certain situations and say, look, that's appropriate or that's not appropriate. For example, if you saw a balustrade with a single pin connection, you might be a little bit concerned. So just something to keep your eyes peeled for. And moving on to pretty much the last topic of it, is we've fully made our way through our glass framing brackets. We've designed for movement, we've designed for tolerance, now we actually need to fix our brackets in place. So I just want to touch on some different types of concrete anchors here, just to kind of go through them and I guess familiarise those of you that aren't already with them, and just explain what are some of the pros and cons of the different types of anchors, because there are a few. So these are probably the four most typical ones we see here in the market at the moment, which are screw bolts, expansion anchors, chemical anchors, and casting chains. Now, just to give you a little bit of context to each one, this is what is called a screw bolt. So essentially, as the name implies, it's just a big screw that you just bang into the concrete. So you do something like you can pass out because everyone goes samples. And then the second one we've got here is what's called an expansion anchor. So it looks like this big fella here. Now, what they do with these essentially is they will bang these into the hole. They come without the nut on top of them, but they bang these into the hole, and essentially they will then torque these up, and as they're torqued up, you can see here that the end of this splays out. Now what that does is it causes friction in the hole and holds the anchor in the hole. So pass it around. There are two types of those. This is a little more fancy one, so it's called an undercut anchor, where the splaying out mechanism is a bit more heavy duty, about $100 more heavy duty. But the third is your chemical anchor. So this is a pretty simple one. Essentially, they get your nice stock standard threaded rod, and essentially they pump a hole full of goo and stick this in there, and then eventually that special goo will dry and give us a nice bond in our concrete. So, and then last but not least is the old casting channel, which I'm sure most of you are familiar with, which is this fella here. So all they do with this essentially is they go around before they actually pour the slab. They tie these into position. If this was our slab edge, they put it somewhere like here in the actual slab. And so when we pour the slab, it will come up to either side here. We have a nice little channel that we can plonk our bracket on, fix into. We use it. There's fancy little things called these T-bolts, which sit nicely inside the channel. Now all of these and many more samples are available in our samples room. If you feel the need to want to go and check them out, or explain them to someone, that's a handy tool sometimes. So as spoken before, we'll just do a quick run through of some of the pros and cons, and then I'll let you get back to your work because it's pretty much the end of it. So there are some major differences here. So particularly screw bolts and chemical anchors, because of the way they work, whether they're just screwed in or if they're just drilled and just put in a hole, they can be used quite close to a slab edge, which can be really useful, particularly in some applications where we're working with tight geometry. Unfortunately, things like our expansion anchors and casting chains are not so good at being used close to the edge of a slab, particularly with the expansion anchor because of the pressure it puts within the concrete when it expands. Usually you might not be able to get that closer than maybe 50 or 60 mil from the edge of a slab, which in some situations is just not possible. In terms of shear capacity and tension capacity, they tend to sort of step up as they do with their associated cost. So the screw bolt, which I showed first off, has got sort of low to moderate strength. Expansion anchors are around about the same, but because there's a little bit more going on with them, they tend to be a little bit more expensive. Chemical anchors are reasonable in shear. They have quite high tensile strength, which is good, but they also come with a bit of a price tag depending on which product you end up using. And the casting anchors, I would probably deem in terms of moderate strength in both situations, and price There's some interesting situations over here. Anchors like these can be dictated by if they can be used in what's called cracked concrete. Quite often see this maybe on, not so much, you would see it in buildings, but not until level you might maybe in a bridge, on the underside of the bridge where the beam or the concrete is in tension essentially, it does develop cracks. Now that obviously has an impact on things such as an expansion anchor which rely on being pressured in the hole. If that hole starts to open, anchor's just going to fall out. So particularly for overhead fixing applications like underslung brackets, which we tend to try to avoid, you need to be careful about what anchors you're using or selecting. So things such as chemical anchors can be suitable. You obviously need to make sure that whatever's being fixed there is propped for a period that can cure. Casting anchors can be used if they're used properly. Some types of expansion anchors, like the first one I showed, are not so good. The undercut is good, but you're going to find it hard sometimes to sell that particular anchor. They may go for a slightly cheaper chemical anchor. And then there's some other really quick ones here at the end. Screw bolts can be difficult to install in slotted brackets. If you can imagine, because you have to screw the anchor, they kind of need to get everything in position and then sort of put it in. It doesn't really give you as much flexibility as something like a chemical anchor or an expansion anchor, which they can bang into the hole without the nut, get it all sorted, and then just put the nut. Quality of installation is critical to expansion anchors. As I said, if they don't torque them up enough, they rely on friction, so they can just pop out. Same for chemical anchors. If they don't clean the holes, or if they don't use the right procedures, the chemical inside may not set, or it might just not be enough of it, and then the anchor's as good as useless. And then casting anchors, there's probably a few here at the bottom. Some good ones, they allow that tolerance we spoke about before. They are pretty quick when you're installing panels, and they can also be sort of modified to suit in different applications. You can remove the legs and weld them to steel and stuff, so they're pretty useful. And that is it. That's it.
Well done.
And there's something interesting.
Me too.
We were talking about deflection before and how in certain cases with the two-edge support,
Yep.
IGUs aren't appropriate. Laminates with a two-edge support, does that have the same issue where it could delaminate, or is that different?
It tends to not be as much of an issue.
Okay.
Yeah, no, it's the seal inside the IGUs is a little bit more critical. There may be a small section of edge which might sort of deteriorate slightly, but typically it doesn't really affect the performance of the panel. There is actually a level of sort of, I guess, like edge bleed on laminate that's usually minimal anyway, so it's not as much of an issue.
Great.
That's a very good question. There are ones, and my apologies for those.
I've got a comment.
Yes.
I just had a comment floating around here that this presentation probably might be a good idea if this presentation was form part of the graduate facade induction.
It's funny that you say that because I just put up there is a technical note which I prepared a few years back.
Okay.
Sort of touched on some of this, but it could definitely do with I think a revamp to include quite a bit of this content. Because I think it's a bit outdated now. So so apologies for those out to sit through it that were familiar with everything I spoke about. I was just trying to sort of give a kind of an overview of the engineering process, and then maybe try and give a few more tools that you can just think about or implement every day to day, or maybe not. So, any more questions or? All good? All right.